this question is about probability generating functions, and for this you can use some of the formula in the formula book. So it starts out by telling us we've got our random variable. Now here we're saying this is binomial. Okay, so that's the notation for binomial. It's got this probability generating function, and part A says write down the value of n and p. So a bit of a hint with write down, it should be something we can do very easily. So if you look into your formula book, you can find under binomial, it's got the probability generating function here. So we can just match this up. Now, as you can see, it should be 1 minus the probability, so that bit's 0.4, plus the probability, 0.6, times t to the power of n, 2. So therefore, n equals 2, that's the power, and p is 0.6, that's the number in front of the t in this form. Okay, now we want to use our probability generating function to find the probability x is 1. Notice they are forcing us, so you're going to have to show some working to show you've used this. Right, the probability x is 1 is the coefficient of t in our generating function. That means we're going to have to expand it. So if you expand your probability generating function, you'll get this. And then you can see that the coefficient of t is 0.48, so the probability x equals 1, 0.48. It then wants the expected value. Now this is also in your formula books if you've forgotten it. So I've got the formula book here, and it tells us here the expected value of x is d dash of x. 1, so I want to do. Okay, so I want to differentiate my function and then substitute in 1. So if I differentiate it, I'm going to get 0.48. So 0.16 is going to go 0.48 plus 2 times 0.36 times t, and we're going to sub in 1. So that's going to give us 1.2. Right, the last one says use calculus to show that e of y squared is this. Now y is the random variable x1 plus x2, and this means, because they've said use calculus, you're not allowed to just generate a table for y and then work out the expected value of y squared from that. Now the mark scheme way of doing this is the one I'm going to show you. There is another method which uses calculus, which in the mock we allowed because this is just a sample assessment, and so we didn't have alternative mark schemes and things, but I'll show you the one they're expecting you to use, and this involves combining a couple of bits of information. Now, first of all, let's work out what our generating function for y is going to be. Now, using this information from the formula book, okay, so if you add two independent variables here, x and y, then that's the same. So for r1, we want g of y as t. That's going to be the same as g of x of t times g of x t. So taking our generating function, it's easiest to use the original form. I'm just going to square that. So that's going to be to the power of 4. Now we need to combine some knowledge of discrete random variables with our probability generating functions. So you should know that the variance of y is the expected value of y squared minus the expected value of y all squared. So that means if I rearrange that formula, the expected value of y squared is the variance of y plus the mean squared. Now I'm going to bring in the probability generating function definitions here from the formula book. So the formula for variance is g dash dash y of 1 plus g dash y of 1 minus g dash y of 1 squared. And then the formula for expected value of y is g dash y of 1, and then I want to square that. And you can then see that those two are going to cancel out. So the expected value of y squared is g of y differentiated twice sub in 1 plus g of y differentiated once sub in 1. And if you do that first, that's just going to save you a little bit of work. So all we need to do now is differentiate y. Now this is where it's handy to use this form rather than expanded form, because you can just differentiate using the chain rule and it drops out quite quickly rather than having tons of long expressions and t's everywhere. So for 0.4 cube, no, cubed on the outside. Okay, and then once you've differentiated, it's not there, you want to sub in 1. Okay, and then we want to differentiate that again. I'm just going to substitute in numbers, so I didn't even simplify that in the meantime. And there's going to be times another 0.6. Okay, and then I'm going to substitute in 1. Okay, so once I've got my two numbers, I can just say the expected value of y squared using my formula from above here. It's always worth putting some sort of statement to say you've proved what they wanted you to prove.